just a bit on asymptotes. Okay. So when we're drawing our sketches, remember, okay, curves will always bend towards the asymptotes. Okay. As I mentioned before, they'll never cut a vertical asymptote, but it is okay to cut a horizontal or an oblique one, because they're telling us what happens out at infinity, out of the extremities, plus or minus infinity. If we're dealing with polynomials and fractions, if you do a polynomial division, remember, when you do a polynomial division, you get a quotient and a remainder. So you rewrite the fraction as quotient plus remainder over divisor. When it's in that form, it tells you a heck of a lot. Because we know the bottom of the fraction can't equal 0. That's how we find our vertical asymptotes. It turns out the quotient will be the horizontal or oblique asymptote. So whatever that quotient is, that's going to be the horizontal or oblique asymptote. Now, it's allowed to cross the horizontal or oblique one, and that's where the remainder comes in handy. Because you solve the remainder equals 0, and if it has a solution, then that's where it will cut the horizontal or oblique asymptote. If it has no solutions, then it won't cut it. Alright, let's have a look at this one. I haven't done the polynomial division yet to see all those features, but nicely it is factorised for me, which allows me to find some x-intercepts rather easily. So let's pull it apart. I'll do the polynomial division. So the bottom of the fraction is x squared minus 1. Top of the fraction is x squared plus x minus 6. And if you remember from polynomial division, it's the leading terms that you're dividing. So x squared into x squared goes once. X squared minus 1. We do a subtraction. There's our remainder, because x squared doesn't go into x. So I could rewrite that fraction as the quotient, 1, plus the remainder, x minus 5, over the denominator. And in that form, tells me a heck of a lot. All right, let's pull it apart. I know, looking at the original equation, which was nicely factorised for me, the x-intercepts will be at minus 3 and 2. Remember, if you got fraction equals 0, because that's basically what you're solving to get your x-intercepts, it's just the top of the fraction you worry about. So top of the fraction equals 0, negative 3 and 2, x-intercepts. Y-intercepts, oh well, we just sub in 0 and we get 6. There's my y-intercept. I know there's going to be vertical asymptotes at plus or minus 1. Draw those in. There is going to be a horizontal asymptote at positive 1. Draw that one in. Question is, will it cut this particular asymptote? And in this case, yes it will. Because if I look at the remainder, x minus 5, it is possible for that to be 0. So it will cut it at x equals 5. So I also now know the curve goes through 5, 1. That should be enough information to draw a rough sketch. When I add to that the fact that curves will always bend towards the asymptotes, and I've got to go through those particular points. So what does this curve do? Okay, over here on the left hand side, a bit like a hyperbola, I guess. Has to bend towards the asymptote, go through negative 3, bend towards this asymptote. It's really the only thing it could do. Now in between minus 1 and 1, it's got to go through 6 and bend towards the asymptote. So it could be a U shape, it could be an upside down U shape, or it might be a twisting shape. However, I know that there's no x-intercepts in between minus 1 and 1. I also know it doesn't cut the horizontal asymptote between minus 1 and 1. So the only option is the U shape. Now this last bit, it's got to go through 2. It's got to go through that 0.51, and it's got to bend towards the asymptotes. Not easy to do in PowerPoint, well, trust me. A little bit dodgy there, but I got it. So it bends towards the asymptote, it goes through 2, it goes through 5, so it's going up, but at some point it must turn and come back down to bend towards the asymptote. As I say, very hard to do given the constraints of what you can do in PowerPoint. Let's have a look at this one. Again, nicely factorised for me already. I'll do a polynomial division. X squared into x cubed goes x. We can do a subtraction. We can keep going. X squared into minus x squared is minus 1. And I've got a remainder of 4x minus 4. So I could rewrite that one as x minus 1. So I've got an oblique asymptote this time. It's the line y equals x minus 1. Okay, x-intercepts. Go back to the original. I can see I've got 2, 1, and negative 1. Plot those. Y-intercepts, substitute in 0, and we get negative 1/3. I'll plot that in. Ooh, that doesn't give me much room to play with, but okay. Vertical asymptotes, bottom of the fraction can't equal 0. So negative 2, positive 3. And we have our oblique asymptote of y equals x minus 1. Well, I actually already now know that it does cut because it's gone straight through my x-intercept that I've already identified. But let's just double check. Top of that fraction, the remainder equals 0. Sure enough, that gives me x equals 1. Okay, what on earth is this curve going to do? Look at the left-hand side. I've got no points here. So how on earth can I tell what it's going to do? Well, because it's got no points, there's only one thing it can do. It's trapped inside this little triangle down here. Because if it was going to bend towards these asymptotes, I would need an x-intercept. And I haven't got one. So, whoop. Oh. There we go. Draw that in. There we go. Did I do the middle bit next or did I go to the right-hand side? Because if you look at the right-hand side, a similar thing is going to happen. This curve, if it's going to bend towards its asymptotes, I'm going to be trapped in that triangle there, or it would come down like so. But I don't have an x-intercept. So I must be trapped up there. Now, if I know me, I probably did that next, did I? Let's see what happens. Oh, no, I didn't. See, I would have thought I would have done that next. All right, let's have a look at that middle bit then. I got to go through these points. I got to bend towards the asymptotes. So once again, really, there's only one thing I could do. I can't start down here at negative infinity, because in order to do that, to get to negative 1, I would have to cut the oblique asymptote. But I know there's only one spot that happens, and that's over here at 1. So if I can't go that way, I must be coming down. Of course, another way you could check is just substitute a number in and see if it ends up positive or negative. So we're starting up here. We go through minus 1. We've got to go through our y-intercept. We know it goes through 1. I've got to come back down and hit 2. So I must turn before hitting the asymptote, because there's only one point of intersection. Come back down and then bend towards my asymptote. And I'll just finish off the curve with the little triangle in there. Beautiful graph. Without doing any calculus. It's not bad for a rough sketch. As I say, calculus will allow us to find those turning points exactly, where it inflects exactly, things like that. Okay.